Okay, so let's continue our discussion. Translations of sine and cosine curves. The graphs of y equals a sine quantity bx minus c is equal to a sine b times the quantity x minus c over b. And the same is true with cosine. Y equals a cosine quantity bx minus c, which is equal to a cosine b quantity x minus c over b. And they have what we call a directed horizontal shift of c over b. In other words, it's also referred to as a phase shift. A phase shift, more specifically, when you do look at that quantity, of which we say it's a phase shift left or right. So let's take a look. Example 3. It says sketch the graph of the following. And again, we're going to list the 5 key points. Y equals cosine of x minus pi over 2. So the features that I want to highlight first and foremost are the a value here, the b value here, and we won't actually be factoring anything out in this case because it just simply is 1. If it wasn't 1, then I would actually be factoring, and I'd have a more distinct quantity that would be x minus c over b in parentheses, where b would be outside of parentheses. In this case, b is actually 1, so that's fine. And then in turn, we can say that c over b is this entire quantity. Okay. Turns out, because we again already know what b is, we can assess that c technically, if b is equal to 1, then c must also be pi over 2. Okay. So let's make that quick assessment. Okay, so and really by virtue of that aspect also we're able to establish that pi over 2, because it is just that, that's going to be indicative of a shift to the right. And that's going to help us when we put together our XY table. And I do recommend very strongly that you continue your XY table as you proceed through graphing these trig functions. So we'll go ahead and make our XY table here. And I'll go ahead and make my XY table as simply as I can, which technically, if you think about it, is also a theta y table in the context of the angle being theta. We will be graphing in terms of x and y, but really x and theta are one and the same. Now the 5 key points that we typically use for a cosine function, thanks again to the idea that the period of cosine is 2 pi. In general, the period is 2 pi divided by b, so we'll make that connection as well. Period is 2 pi divided by 1, so the period is 2 pi. So there's no real difference as far as the period goes. But because we're shifting it to the right, we're going to have to add a nuance from 0 to 2 pi, cutting that in half, of course, such that we have pi, and then cutting that in half so that we have pi over 2. So we're going to go up by halves of pi. 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2, of course, which is 2 pi. But again, because we're shifting it to the right, we'll be adding that increment to each respective x coordinate or x value that we're typically used to using as such. So, adding pi over 2 to each respective typical x will yield, as you're about to see here in a moment, the first value of which is pi over 2. The second would be 2 pi over 2 or pi, and then 3 pi over 2, because 2 pi over 2 plus 1 pi over 2 is just that, and then 3 plus 1, of course, 4 pi over 2, so 2 pi, and then the last one, of course, 2 pi over 2 plus 1 pi over 2, or 4 pi over 2 plus 1 pi over 2, which would be 5 pi over 2. The amplitude, which again I can argue simply by looking at the absolute value of the a value in front of the function, which is just 1, that's not going to do any vertical stretch nor shrink to the function. So that's simply what we're looking at. Go ahead and plug in pi over 2. So pi over 2 minus pi over 2 is 0. The cosine of 0, of course, is 1. 1 times 1 is 1. Okay, plugging in pi minus pi over 2. So in other words, 2 pi over 2 minus pi over 2, which is pi over 2, the cosine of which is 0 times anything is 0. And then this should proceed accordingly. 3 pi over 2 minus pi over 2, That's 2 pi over 2, which is pi. Cosine of pi, -1. -1 times 1, -1. And so on and so forth. So all of these values should end up being the exact same outputs for a basic cosine function graph, except, of course, we are looking at it from the standpoint of shifting it to the right. So let's graph. And graphing, we'll go ahead and use our XY axis that I probably can maybe pull out as such so that I can maybe graph maybe more than just one single period. So I'll go through and I'll start maybe with the parent function. The parent function that we're comparing it to simply would be y equals cosine of x. I do want to assess and use those similar key points from before. So pi over 2, pi, 3 pi over 2, and 2 pi. But again, because I'm shifting it to the right, it's more than just that. It's also 5 pi over 2, which comes after 4 pi over 2, or 2 pi. Again, shifting it to the right should give us one more increment as such by pi over 2. Okay, so the parent function, again, only up as high as 1 and as low as -1, takes shape as such. The cosine of 0 is 1. The cosine of pi over 2 is 0. And so on and so forth. Cosine of pi is -1, cosine of 3 pi over 2 is 0, and then back up with one full period up at 2 pi, comma 1. So this is the graph of the parent function. As you can see. If you were to type this into your graphing calculator, it would certainly be in radian mode. And compare the parent to the transformed graph, of which we see as pi over 2 comma 1, pi comma 0. I'm looking at the XY table value of values. So 3 pi over 2 -1, and 2 pi 0. And of course that last value of which, 5 pi over 2, we had to add. And that then is of course the last point. And your full period is again established. It's still a period of 2 pi. There's no change there. But again, it's shifted to the right, pi over 2. Okay. If you did extend the idea in terms of more than just one period, we could copy and paste this graph off to the left. I'll spend some extra time later and I'll make that graph, put it together in such a way and make it where you can see the red curve to the left as well as the blue curve to the left. So you can see kind of two nice periods conveyed. I'll do that at a later time for you. Part B, so we're going to go and establish yet again in looking at some of the values. In this particular case, I'll start the process, however, of rewriting it so that we do, in fact, have a B value. We're going to factor this number such that it's, well, 2 sine 2 times the quantity. We're factoring it or dividing it out. So dividing it out, of course, leaves us then with x, but pi over 2 divided by 2, or multiplying it by a half, is going to yield pi over 4. Okay, so that hopefully then should be indicative. I'll put parentheses around this as well because that entire angle is what we're taking the sine of. Should be indicative of a B value more specific to, as you can see, a constant of 2. Our A value, absolute value of which we can establish there as 2. Okay, I'll erase that for now. Don't want to confuse the issue there. And then we can calculate our period as 2 pi over 2, which is your B value, or pi. So the period is pi. Okay, and then we can establish some more things in terms of, well, this value, right? The amplitude of 2 does indicate something specific. In a moment I'll describe that. Let's talk about C over B, which in this case is pi over 4. The entire quantity is just that. And because I've put it together in such a way where it is already simplified with B factored out, the essential understanding here simply is that you're shifting it to the left, pi over 4. Let's continue our ideas with all the other aspects, particularly with the period being less than 2 pi. That is something we refer to as a horizontal shrink. Okay, and then for the other aspect, which again we started off there with an amplitude of 2, because that happens to be greater than 1, that is a vertical stretch. We have seen vertical stretches before with other functions. With trig functions, it's really very similar. Okay, so we'll make an xy table, which again we'll denote as a kind of x equals theta y table. We're still going to make 5 key points, but remember we are shifting it as well as stretching it. Okay, so I'm going to go ahead and as we typically have seen before, we denote our period, but in this case from 0 not to 2 pi, but from 0 to pi. If we cut that in half, we're at pi over 2. Half it again, pi over 4. So we're going to go up by fourths. Again, the period is pi, not 2 pi. So 0, 1/4 pi, 2/4, 3/4 pi, and then lastly 4/4, or just pi. And again, because we are shifting it left by pi over 4, we're going to subtract pi over 4. Okay, this is going to give us a nice depiction of how the parent function and this new graph will compare with these particular transformations in mind. Subtracting pi over 4 to those respective 5 typical key points will yield, well, let's see, 0 minus pi over 4, that's negative pi over 4, and then 0, and then pi over 4, because 2/4 minus 1/4 is 1/4, and then 2 pi over 4, so pi over 2, and then lastly 4/4 minus 1/4, of course, 3/4, so 3 pi over 4. Okay, so if we plug in negative pi over 4, and I do recommend you plug in all these values to test your theory here. If you plug in negative pi over 4 into, let's say, this right here, this version, you get negative pi over 4 plus pi over 4, which is 0. 2 times 0, of course, is 0. The sign of 0, of course, is the y-coordinate of which is, of that number of radians, of which is simply 0. Times 2 is 0. Plugging in 0, so we have pi over 4 times 2, which is pi over 2. The sign of pi over 2 is 1 times 2 is 2. And so on and so forth. Plug in pi over 4. That's 2 pi over 4, which is pi over 2, times 2, which is pi, the sign of which is 0, times 2, of course, is 0. Keep going. If you plug in pi over 2 minus, plus pi over 4 is 2/4 plus 1/4, or 3/4, times 2 would be 3/2. So you've got sine of 3 pi over 2, which is negative 1 times 2, which is negative 2. Okay. As you can see, the pattern's continuing in a nice manner where we really don't stress about, any other angles besides the one on the axes. So as you can finish up, you'll see, or as you finish up, 3 pi over 4 plus pi over 4, that's 4 pi over 4, which is, of course, pi. Times 2, that's 2 pi. So you actually go full around in one revolution. The sine of 2 pi, of course, is 0, times 2 is 0. Okay, so these respective outputs put together with those inputs, let's see how the graph takes shape. We'll go from there. All right. I will again graph the kind of left period of the graph after I just simply graph the right or positive period here. Now I do want to be mindful though that because I am going up by fourths, that we make our scaling a little bit more specific here and more careful. So I'm going to go up by 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8/4. 8/4, of course, puts us at 2 pi. And if again we went up by fourths, there's 1/4, 2/4, 2/4 is a half. 3/4, 4/4 or pi, 5/4, 6/4 or 3 pi over 2, 7/4, and like I said, 8/4. We are going to go up higher this time, so we'll stretch it up to 2 and down to negative 2. I will be graphing the parent function as well, and we'll go ahead and finish this up in another video.